In this video, we're going to look at page 58, which is 45, 45, 90 special right triangles. So 45, 45, 90 degree triangles are triangles who have those angles as their measure. So they're a right triangle, and then the other two angles are both 45. On this type of triangle, two of the sides adjacent to the right angle are congruent. These are called the legs of the triangle, right? So the hypotenuse is the side that's across from the right angle. The sides that form the right angle are the legs. The hypotenuse is the square root of 2 times the length of a leg. And so that means that if the leg is x units long, that the hypotenuse is x times the square root of 2. So if we think about the legs as individuals, that means that they're in the ratio of 1 to 1 to radical 2, meaning that if I were to multiply all of those by the same number, that will give me the set of values that represent the sides of the right triangle. What we're going to use to help us solve problems is a table. The table is written right below there. So we're going to write 45, 45, 90. So the side across from each 45 degree angle is x. So that's the way that this table works, is that 45 is across from x. And since both of those are the same 45s, that means that those sides are both x. I'm not going to leave those lines there. And then across from 90 degrees is x radical 2. Okay, so say that x was 5, that would mean that the sides were 5, 5, and 5 radical 2. So what we're going to do on the inside of this page is look at different combinations of sides on a special right triangle that is a 45, 45, 90 right triangle. So on the inside, we've got a big table where some of the pieces are already filled out, and then we're using it to fill in the rest. And then on the other side, we've got some triangles, so we're gonna use that to identify some pieces on by creating a table on our own. So for the first one, we have 8 and 8. So notice that those are under x. So what this tells us is that x is 8. So if x is 8, then x radical 2 is just 8 radical 2. So there's nothing that I really have to do there except that look at what is the value of 8 and be able to plug that in. So then for the next one, I have x is 7. And so that means that x radical 2 is 7 radical 2. Okay, so when I know x, I'm just placing that number in front of radical 2 to find the hypotenuse. In terms of the next one, I know now what x radical 2 is. So if x radical 2 is 6 radical 2, that means that x is 6. So that means that these other two sides on the next triangle are 6. And then same thing for this last one. I know that it's 4 times the square root of 2. So x must be 4 then. So the other two sides of the right triangle are 4. For the next one, I know what x is, and they need us to fill in that x is also that next value. So notice that if this x is radical 3, that means that this is radical 3 as well. So then for this last one, I'm multiplying radical 3 times radical 2, which actually gives me a radical 6. So I do want to put the simplified answer there inside the box, not the, I don't want to just write radical 3 times radical 2 because that's not simplified. So I'm going to have to do something similar for the next one because they're telling us that x is 5 times the square root of 7. So that means that the next side is also 5 times the square root of 7. And that would mean that the hypotenuse is 5 times the square root of 7 times the square root of 2. And so I can only multiply the pieces that are under radicals together. So that means that the 5 is going to stay outside the square root. And then the square root of 7 times 2 is 14. So that's going to be 5 times the square root of 14. The next one's a little bit more complicated. So if I think about the relationship that I have here, I have 5 radical 7, 5 radical 7, and then 5 radical 14. If we kind of look at these numbers, notice that 14 is 7 times 2. So if I think about just dividing 14 by 2, that gives me the value for x. So if I think about dividing the number inside the radical by 2, that would mean that this would be 2 radical 5 for x. Okay, and I can check that again by checking, is 2 radical 5 times radical 2, does that give me that radical 10? And it does. So when I know that value for the hypotenuse and I have a number inside a radical, it's half of that number is what ends up in the radical for the other two sides of the triangle. So then for the next one, it's kind of like the first two that I had in that previous set, where I know x. So if x is 3 radical 2, then this one's also 3 radical 2. And then if I multiply 3 radical 2 times radical 2, those radicals cancel. And that's like having 3 times the square root of 4. So this is actually just going to be the number 6. Okay, so notice that I had a radical 2 in the x, and that turned out that I didn't have a radical left in my hypotenuse. So if I have 7 radical 2 for x, then 7 radical 2 times radical 2 is going to give us 7 times 2, which is 14. So for the last one, I have 30. And so 30 is x times radical 2. So again, if I look at my pattern here, I have 7 radical 2, 7 radical 2, 14. 14 is double of 7. So if I were to divide 14 by 2, I get 7, and I just have to multiply it by that radical 2, and that's our pattern. So if I divide 30 by 2, that's 15. So this is going to be 15 times the square root of 2. 15 times the square root of 2. This last one's a little bit more complicated because 21 is not an even number. So it will fit the same pattern, it's just not going to be as pretty, because 21 divided by 2 gives me a decimal. So I want to write that as just 21 over 2 times radical 2. So half of 21 times the square root of 2 is that missing leg. Okay, so for these last three, we've got a triangle. So we're going to create the table ourselves. So when we do this, we're going to draw a table so that we have our 45 degree, 45 degree, 90 degree angles so that we can find our x, and our x root 2. So if I look at my triangle, this 45 is 8. So I'm going to say that that's that guy. So then if I think about this, this is another 45 degree angle. So that means that that is also 8. And so then across from 90, then if x is 8, this is going to be x times the square root of 2. So I'm going to create that table each time that I'm doing a problem to organize my work. So I've got 45 degrees, 45 degrees, and 90 degrees. And I have again across from a 45. This time I have 7 times radical 2. So this gives me 7 root 2. So that means that this is also 7 root 2. So remember that to find this one, I'm doing 7 root 2 times root 2. So what ends up happening is I'm losing that radical and doubling the 7. So that's going to give us 14. And then for our last one, we're going to have a 45, 45, 90 right triangle. Sides x, x, and x root 2. And then looking at this one, this time they give us something that's across from the 90. So they give us that this side is 22. So when our hypotenuse is a whole number, that's when our value here is half of that. So 11 times the square root of 2. 11 times the square root of 2. So then that means that those are the sides of that right triangle. So this pattern is a 45, 45, 90 right triangle. In the next lesson, we're going to look at a 30, 60, 90 right triangle. So there will be 2 patterns in this unit that we will be talking about for these concepts.